Hi everyone, Ryan Jackson here. Hope you're having a great day. We're going to take a peek at some of the new and deleted articles in the 2023 NEC, and we're going to start right now. All right, talk about with the 2023 NEC as far as global code-wide changes. One of the things that happened is the NFPA Standards Council ultimately issued a document called the NEC Style Manual. Now, the Style Manual has been around for a very long time, but they updated the NEC Style Manual to incorporate some new changes, and they had to change the National Electrical Code to correlate with those changes in the Style Manual. So the Style Manual is a document that tells you how to write another document. So everybody that writes has a style manual. I mean, my books follow a certain style manual. You know, we use the Oxford comma, and we say must instead of shall, and different things like that. And of course, the style manual for the NEC is going to say, it's going to talk about the structure of the code. You know, we have the 210.70, and then it'll be A and B and C, and then A and A1 and A2, etc. So it'll tell us how the code kind of is structured. It will also tell us how it's formatted, how it works as a document. And one of the things that happened is they changed the style manual to say, look, we want all of the definitions to go to Article 100. And that happened, and that is the case in the 2023. I'm going to do a separate video covering that. You know me and my definitions. I love to talk about them, but it's really, really important, and it's going to take a lot of getting used to. So I'm going to do a separate video on the definitions. They also made some code-wide changes to address the style manual to make sure that, you know, try to limit repetitive information, things like that. So all in all, I think the 2023 NEC is a better book than the 2020 NEC, and I think the 2020 was better than the 2017 NEC as far as usability. So we'll talk more about those in another video. Today I want to focus on new articles and deleted articles. Several articles were created for systems exceeding 1,000 volts AC or 1,500 volts DC. Existing requirements for such systems were relocated from several articles. Okay, so if you're familiar with the NEC and you've ever dealt with medium voltage, I mean, listen, a lot of us, and probably most of us, never really get into systems exceeding 1,000 volts. But there's a lot of people that do. And it was really tough because trying to find all the requirements for medium voltage, and I say medium voltage is anything over 1,000 volts. So finding the requirements for medium voltage could be kind of tricky. And I'm going to be honest, as they went through the process, my eyes were opened as to just how much material wasn't really there in the 2020 code. I mean, look, I know that it's going to be tough to wire a customer-owned substation that's, 130,000 volts. That's going to be tough to do straight out of the National Electrical Code. It was never really intended for that. You're going to need help from other documents like the National Electrical Safety Code. I knew that it wasn't perfect, but I didn't know quite how much material was missing or in the wrong section or the wrong article until they actually made these changes. So they went ahead and changed everything so you won't have like part 2 of or part 10 of Article 240 used to be for over 1,000 volts. That's gone. Part 8 or whatever from Article 230 that covered over 1,000 volts, that's gone. They kind of made their own articles for all of the medium and higher voltage applications, which I think is really a good move. So now you're going to have Article 235, which covers branch circuits, feeders, and services over 1,000 volts AC or 1,500 volts DC. Article 245 covers the overcurrent protection. Article 245 is actually a lot bigger than you might think. If you went to Part 10, or I think it was Part 10, maybe it was Part 9 of Article 240 in previous versions, seriously only like 2 paragraphs of 1,000 volts. And when you get into Article 245 in the 2023 NEC, you're going to find that it's a lot bigger than just 2 paragraphs. And that's because they relocated some of the stuff out of what used to be Article 490 and moved it over to Article 245. And like I mentioned, this effort made everyone aware that maybe we needed some new requirements and provisions for these systems. So Article 245 is overcurrent protection. Article 305 is general requirements. That's going to be just like the Article 300 for 1,000 volts and less. Now we have Article 305 for over 1,000 volts. Article 315 is new, although really it was Article 311, and that's where this came from. In the 2017 code, Article 310 covered conductors. And then in the 2020 code, Article 310 covered conductors for 2,000 volts and less, and they created a new Article 311 for over 2,000 volts. And I got to tell you, I love that change. Not that I do a lot of medium voltage stuff, but it made Article 310 a lot smaller so that I could focus on the majority of my customers, which is less than 2,000 volts. So it made it a better code book. So Article 311 was created, and I think the correlating committee realized that it was a good move. And they decided to make all of these changes to create their own articles. So Article 311 is now Article 315, and you can see the pattern here. All of these end with a 5, and that's by design. Article 395, which used to be 399, is outdoor overhead wiring. And what used to be Article 490 is now Article 495. So again, this is all for the over 1,000 volts AC or over 1,500 volts DC stuff. So Article 235 has a scope. It says, look, this article covers services, feeders, and branch circuits over 1,000 volts AC or 1,500 volts DC nominal. So there you go. If you're working in this customer-owned substation here, then you'd want to find yourself in Article 235. Now, as I mentioned earlier, probably not going to wire that substation without a little outside help as far as the NEC is concerned. And this note tells us that. It says, look, take a look at ANSI IEEE C2 2017 edition, which is the National Electrical Safety Code, for more information on these voltage levels. This is what the utilities follow. This is what, even if you are an NEC regulated installation, if you're doing this kind of work, you're going to need to bring in the National Electrical Safety Code as well. Article 245, as I mentioned, overcurrent protection for over 1,000 volts. So there you go. If these massive rack-in power circuit breaker, vacuum circuit breakers, if these are your world, then this is where you'd find it, Article 205. And then Article 305, general requirements for these medium voltage, higher voltage installations. All right. The other new articles that came out. We have a new Article 369 for insulated bus pipe or tubular covered conductors. Now you'll notice that this is in Chapter 3, which means it's a wiring method, right? So to get wires or to get electricity from point A to point B, we can use Article 369. And now we can also use Article 371, flexible bus systems. Now here's the thing. These two are very much still in their prototype. There is an outline of investigation created by UL. I'm not sure if there's an actual product standard yet. There might be. But these things are brand new. They're not going to be something that you've really seen yet. And they're mainly going to be for medium voltage and for high amounts of current. You're not going to wire your house with this stuff. And in fact, you're not even going to wire a commercial building. This is going to be if you've got a vault, like if you buy your power at 35,000 volts and you want to move it down to 12,470 and then move it down to 480 inside of your building, this might be for you. Article 512, cannabis oil equipment and systems using flammable materials. All right. Depending on what state you live in, obviously, you might find a cannabis oil extraction facility. Now, we've been extracting oils from plants for a very long time. It's not just cannabis that uses this type of equipment. You can extract lavender oil, things like that, and sell it as essential oils. So extracting oils is not new, regardless of where you might be. But let's be honest, it's 2022. Right when I'm recording this. There's a reason we added this article in 2022 and not 1922. It's because of cannabis. So, cannabis oil equipment and systems using flammable materials. When they extract the oil from the cannabis, and I'm trying to use the right word here and not just say pot and dubage and stuff like that. When you extract the good stuff from the plant, you usually use flammable materials like ethanol and butane And of course, when you're using that, you're going to have some hazardous locations around it. So Article 512 was new. Most of it is having to do with how you classify the locations. It's going to be very similar to paint spray booths, if you're familiar with those. The other article that they added is also a new technology, and that's Class 4 Fault Managed Power Systems in Article 726. And these are pretty interesting. I'll talk about those here in just one second. Now, as I mentioned, when it comes to insulated bus pipe, I don't have any good photographs of it because it doesn't really even exist yet. They've used it on on big aircraft carriers and things like that in marine applications. Now it's just getting to the point where we can actually use it in a building. This photograph here is at the power plant where I teach every year, and it's very similar. This is basically insulated bus pipe on steroids. Okay, you're not going to run into something this big in an NEC regulated application. This is 26,000 volts, 22,000 amps, and yes, that is phase A, phase B, and phase C. So you've got this massive pipe, a duct, and inside of it you've got basically bus bars. And one of the things that this allows you to do, and you can see it in the picture, number one, you're not going to be able to move this kind of power with a literal wire. I mean, what kind of voltage, what kind of insulation is good for 26,000 volts? There is none. What size of wire is good for 22,000 amps? There is none. But imagine if you could, if this was a cable, a conductor, what would the bending radius on something like that be? When you have to change directions, it would be almost impossible. So what they have here is basically, and I'm talking about the NEC version now, the insulated bus pipe. It looks like this, okay? It's a smaller version of that. So you've got these bus bars inside of the duct, and they get bolted together at certain intervals. And really what this allows you to do, as you can see, is it allows you to change directions. So if I'm going 90 degrees, then you can do it with this joint right here, and that's what you're going to see in an Article 369 application. So this is something that, you know, if you're really into big systems, you might see it in the near future. You might also see the new Article 371, which is flexible bus systems and their associated fittings. This is a cool product, and by the way, I want to shout out my friends at NVent for these photographs. That's who manufactures this stuff. And again, I don't have any real photographs of it because it doesn't really exist yet. They've built it. There's a couple of applications where it's up and running, but you might see it in a 2023 NEC regulated installation. It's exactly what it sounds like. It's a bus. Okay, so it's a bus bar, but it's flexible. There you go. It's a flexible bus bar. This is what it looks like from the outside, and you can see the bolt holes that match the ANSI configurations for switchgear and all of that stuff. And then if you were to cut it open, you'd see that it's actually built of super fine stranded conductors like this, and that's what gives it its flexibility. So here is a cross section of it. And you can see the little angel hair size pieces of wire sticking out. There you go. It's a flexible bus. Now, you're not just going to run this stuff up in a ceiling, right? I mean, it's insulated, but it's still, it's a bus bar. So you're not going to be wiring a small building with it. This is to move a lot of current from point A to point B. You're not going to go from a little 200 amp panel to another 200 amp panel with this. This is like something where I want to go from a transformer to a switchboard with 4,000 amps or something. This is kind of a design that NVent created to show what you might use this product for. So here I've got this massive medium voltage transformer. Maybe it's stepping it down to 480 volts in my building. And I'm going to run insulated flexible bus over here to my switchboard. And you can see we run it up onto a cable tray. And then we have some support brackets here. We run this flexible bus, and then we hit a transition box, and then we go down here and we bolt it right into the lugs of the switchboard or switchgear. So it would be fed, it would be fed like not like a main breaker application, main lug. I don't know why I couldn't find that term. So there you go. That's where you would see flexible bus systems. And again, I'm looking forward to getting an actual photograph of an installation once we're able to put this product into play. Article 512. So this is a picture of my basement here. I'm just kidding. This is a cannabis facility in Colorado. So Article 512 covers cannabis oil preparation. Here's the thing. Most of Article 512 is not necessary. It says, follow instructions and follow Article 501 and wire it in accordance with Article 501. Well, right, because it's a Class 1 location. So most of the stuff in Article 512, it really isn't necessary. Just shoot you back to Article 501. What's really nice, though, is it's got some specific area classifications. These things are getting popular enough that we want to be able to classify them consistently no matter where you're installing them. Think of a gas station, right? We've got, tens of thousands of gas stations in the United States, and the code tells us exactly how to classify the areas. What if it didn't? What if the code treated it like oil refineries or what have you and just says, hey, wherever there's an explosion danger, it needs to be classified as a Class 1 location? You would have an inspector in California saying, okay, well, that means it's going to be classified within 18 inches of the dispenser and 18 inches up. And you might have an inspector in New York saying, well, I don't think it's 18, I think it's 24. You might have an inspector in Chicago that says, I think it's only 6 inches. Look, they're gas stations. We've got them pretty well figured out. We should be able to classify them all the same. That's what we're doing here with Article 512. We're saying, look, it's a cannabis oil booth. And as I said, it's going to be a lot like a paint spray booth. You buy a booth, it's a listed assembly, it's got a door, it's got windows, it's got interior lighting built into it, and the space within 3 feet of the door is going to be classified depending on ventilation, things like that. So if your world involves cannabis oil extraction, you're going to love Article 512. It makes things easier and more consistent and more predictable. Article 726 is brand new, and I'm probably going to try to do a joint video with the manufacturer of this product because it really warrants a longer discussion than I'm going to be able to have. Class 4 circuits. So we have Class 1, Class 2, and Class 3 back in Chapter 7, and now we have Article 726, which is a Class 4 circuit. And basically, it's higher amounts of voltage and power than you could have on a Class 2 or a Class 3 circuit, but it maintains safety not by the power limitation of the source, but by the technology. Think of a Class 2 circuit, like a doorbell. The doorbell is limited in the amount of voltage and current that you can have on the circuit. It's limited by the power source, by the transformer. You can't kill anybody with a doorbell transformer. There's not enough voltage to drive enough current to stop the human heart. You can't light a fire with it. I mean, you bang the wires together, there's not enough I2R heating to create a fire. So the voltage and power limitations of the power source is what makes a Class 2 or a Class 3 circuit safe. That's not the case with Class 4. With Class 4, I can get much higher voltages, 450 volts peak, and I can get higher levels of current on a Class 4 circuit. So how is that safe? Well, it's safe by the technology. It comes from a transmitter and it ends at a receiver, and it uses a Class 4 cable. Belden has a listed Class 4 cable now. To the best of my knowledge, they're the only ones right now that have the product. But the way this works is it works on the concept of using a handshake, which is, if you're really into low voltage or computers, networking, that should be familiar to you. So 500 times every second. Think about that for a minute. 500 times every second, the transmitter and the receiver communicate with each other, making sure that the circuit is still intact. So 500 times every second, the transmitter asks the receiver, hey, everything looking good? No breaks, no discontinuities, right? And the receiver is going to talk back to the transmitter and say, yep, loud and clear, we're good. If you were to have some sort of disruption, and by that I mean like a fault, so if you were to hit this wire with a hacksaw or something, well, that receiver is going to ask, the transmitter is going to ask the receiver if everything is good, and the receiver is not going to respond. So the transmitter is going to say, well, I guess not, and it shuts off. And it checks 500 times per second. So yeah, it's higher voltage. So what if I got shocked with a voltage of 450 volts peak? That's enough to kill a person. Yeah, but the duration of the shock matters too. If you only get shocked for 1/500th of a second, you can't even perceive that, let alone get injured by it. So this uses safety by the duration of the shock, and make sure, by sending that handshake agreement back and forth to make sure that they're communicating, That's how it ends up being safe. Now, again, I don't have any real world photographs of this because it doesn't really exist yet. There's a company called Volt Server. They're the ones that really push this technology, and they call it digital electricity. Go to their website, take a look. They've done some stadium lighting with this, and they've also got some prototypes for some other installations. So check out Volt Server, and they don't corner the market on this. I mean, everybody else will be able to make it too. But for right now, they're the ones that kind of invented the technology, and they're the ones taking advantage of it. The other thing we did code-wide is some housekeeping in Chapter 7. We got rid of Article 712, DC microgrids. Honestly, it never should have even been in the code. You've got generators and solar and wind and a hydroelectric dam, an energy storage system, and they're all working together, and we're going to call it a microgrid, and let's make a new article. Why? I mean, okay, you got multiple power sources. So what? Good for you. Well, yeah, but I'm tying them together. Right, that's what Article 705 covers. When you have multiple systems working in parallel, it's Article 705. So, Article 712, DC microgrids, we created it, and then we're like, that probably wasn't necessary. Now it's gone, which I think is good. Article 722, cables for power limited and fault managed circuits. This was relocated material from Article 725. So Article 725 now covers just Class 2 and Class 3. It does not cover Class 1 anymore. And it just has the actual requirements, not the cable requirements, but the requirements for the circuit, the power source, the separation requirements, things like that. As far as you can use Class 2 cable and Class 3 cable and CMP cable, and these are the substitutes. And if you penetrate a firewall, you got to do this. And if you, how do you secure them and support them? They moved all of that to Article 722, which I think is good. They also created Article 724, which is for Class 1 power limited remote control and signaling circuits. That used to be in Article 725, wasn't it? Article 725 used to cover Class 1, Class 2, and Class 3. Now it just covers Class 2 and Class 3. Class 1 is now found in Article 724. Okay, so Article 722 covers the general requirements for cables of Class 2 and Class 3 circuits, power limited fire alarm, and Class 4 fault managed power circuits. If you're familiar with Article 800, this is similar to Article 800. So it's one article that just, you know what it does? It removes repetition from the code. Article 725 used to say, hey, these are all the cable types, and these are the properties they have to have, and these are the listing requirements, and this is how you secure and support them. And then Article 760 said the exact same thing for low voltage power limited fire alarm. Why do we need to keep on repeating these things in the code? Let's make a general requirement and give it a new Article 722, and that's what they did. So 725 is new, and it results in Article 725 being smaller and easier to work with. Same with 760. The last thing is Article 724, which is Class 1 circuits. All right, so as I mentioned, Article 725 used to cover Class 1, Class 2, and Class 3 circuits. Now it just covers Class 2 and Class 3. So Article 724 covers Class 1 circuits, but there's one subtle thing here that they did, and I'm going to be interested to see how this plays out. I haven't wrapped my head fully around it quite yet. It only covers power limited Class 1 circuits, which is to say 30 volts and less, and up to, I think, 1500 watts. It's in 724.40. So if you have what we historically called a Class 1 control circuit that's higher than 30 volts, like 120, we don't really call that a Class 1 circuit anymore. We just say it's no different than power and lighting. And really that kind of makes sense. I mean, how do you wire a 120 volt motor control circuit? You don't use thermostat cable, right? You're using EMT, or you're using PVC, or you're using MC cable, and you're using THWN conductors. So why do we have to convolute everything? Oh, that's Class 1 non-power limited. Just call it, the regular Chapter 3 wiring, because that's how we do it anyway. So Article 724 now only goes up to 30 volts, and as such, I think it's going to be used much less often. I think you're going to have Class 2 and Class 3 in Article 725, And then you're going to have Article 300 covering what we used to call a Class 1 non-power limited circuit. All right, those are my global code-wide new deleted articles. Again, I'll get into Article 100 in a different video, and we'll spend a lot of time figuring out how the manipulation of Article 100 and the deletion of all the individual article definitions comes into play. So, with that said, I hope you enjoyed the video. I hope you have a wonderful day, and we'll see you next time. Thanks, everybody. Be sure to like, follow, subscribe, and ring the bell.